Hi, it's me, Dr. Prasad Puthiyillam. Continuing my classes on organic chemistry, basics of organic chemistry, electromeric effect. In previous class, I explained about the inductive effect as well as resonance or mesomeric effect. This particular class is covering hyperconjugation as well as electromeric effect. First one, hyperconjugation. Hyperconjugation is actually it's a stabilizing interaction. It involves a delocalization of the sigma electrons of carbon hydrogen bond of an alkyl group, which is directly attached to another atom, either it is in unsaturated state or with a unshared p orbital. That means having either positive charge or free radical. If it is represented here with a unshared p orbital, that is having a p orbital with no electrons, that is a positive charge is there, and the next carbon we call it as actually alpha carbon. It has got hydrogen, and due to the carbon carbon rotation, this hydrogen may come to the plane of this p orbital. Then there is a possible interaction of this hydrogen with the p orbital, that is the sigma bond of this ch bond will interact with the unshared p orbital, thus forming a stabilizing the positive charge. Okay, so that stabilization is represented here. The shared electrons or sigma bond, it will call shares with that of a positive charge, and hydrogen will get a positive charge. And this representation here in which there was a bond, now this bond is not there, therefore also we call it as double bond, no bond resonance. It is represented in another way here, that is three hydrogen atoms which can form a hyperconjugation to stabilize the positive charge on that CH2 plus. That positive charge can be stabilized or neutralized with that. This electron movement, it can be represented like this. This is the representation of the same thing. So one of the hydrogen which is in the same plane of that of positive charge, the p orbital with positive charge, the CH bond, the electron shift takes place such that it forms a double bond here, and hydrogen will get a positive charge. Okay, then the next moment the electron can even move back. It's a temporary effect, so it can jump back, and a rotation of CH. So when it moves back, it becomes a carbon-carbon single bond here. When the electron density goes back, it again becomes CC, carbon-carbon single bond. Free rotation is possible. The next hydrogen will come to the plane of that p orbital. Therefore, that shifting of electron possibilities are there. That is represented separately with the H plus to that hydrogen, or positive charge to that hydrogen. Further, the electron density goes back, and another possibility, another hydrogen comes to the plane, then there is also a possibility of forming a no bond resonance. Therefore, as the number of hydrogen atoms, alpha hydrogen atom, the atom hydrogen atom connected to the carbon atom, or the atom near to the or next to the p orbital with a positive charge or a free electron, that we call it as a alpha hydrogen atom. As the number of alpha hydrogen atom, if more hydrogen atoms are there to do this type of rearrangement of electron, the positive charge on this carbon will be neutralized further, therefore it will be more stable, that particular carbocation. So this we call as carbocation. The particular carbocation will be more stable. Therefore, the stability of carbocation, it represented like this. CH3 plus is very less stable, whereas CH3 CH2 plus is little bit more stable because it has got three hydrogens which can stabilize the positive charge. Whereas CH3 twice CH plus, it is even more stable than that of previous one. Here, total 6 hydrogen atoms can share the or can donate electron density to that of positive charge to stabilizing that, and the tertiary butyl group it is even more stable. Therefore, in any chemical organic chemical reactions in which the possibility of forming a carbocation is there, the carbocation, even the bond shifting, even the methyl group bond shifting or hydrogen bond shifting takes place in order to stabilize the carbocation. It may be hydride shifter or methylide shifter, also all those concepts we will study in coming classes. Therefore, the one carbocation with more alkyl group substitute or alkyl group connected to that, if it is tertiary, then the carbocation will be more stable. That is well explained by hyperconjugation. Even if it contains a free radical, so previous case we saw a positive charge here, here it is a free radical, that free radical can also be stabilized the same way. Okay, so same way we can represent the stabilization of that free radical also. So both positive charged ion carbon, that is cation, or free radical containing carbon, that both can be stabilized by hyperconjugation. Next one, electromeric effect, which is class E effect. Electromeric effect is also a temporary effect. It is seen with the doubly bonded, multiple bonded organic compounds, that is carbon carbon double bond or carbon carbon triple bond mainly. Not only carbon carbon, any doubly bonded or triply bonded molecules can show this uh, uh, type of electron movement in, that is in presence of an attacking reagent only. That means the pi electrons will jump to either towards the attacking reagent or away from the attacking reagent. If the attacking reagent having a positive charge, then the electron will move towards that, and if it contains attacking reagent contains negative charge, then the electron movement of the pi electron movement takes away from that. So example, with that we can say it as a plus electromeric effect, that pi electrons are transferred to the atom to which the reagent is attached. Say example here, H plus is coming to the carbon atom, the particular carbon atom which is represented here. Then electrons are jumping towards that. Therefore, we can say that it is a plus electromeric effect, and we'll be getting a carbocation. Is another example with the cyanide ions, Cn minus. So when it try to attack, it cannot react with oxygen because already it is negatively charged oxygen, whereas carbon it can form a bond. Therefore, the cyanide group will be going to connect with that of carbon, and the electron movement is in the pi system. It is away from the attacking reagent. Therefore, we call it as minus inductive effect, minus electromeric effect. Hope you understood these two concepts of hyperconjugation and electromeric effect. Uh, Thanks for watching this video and have a nice day.